Good day, everyone. I welcome you all to doctorate class once again. Today, we're going to look at basic concepts that can help you understand wave while studying it. To make it easier, we're going to start with the wave itself. You need to know the meaning of wave, understand the meaning of the concept pulse or ripple, understand phase difference, wave number, wave front, and wave propagation. Now, let's start with the wave itself. Different textbooks can define it in different ways. Different teachers can explain it in different ways. I can assure you they're all correct. But for this class, I will tell you that wave is a disturbance that takes energy from one point to another in a medium without causing any permanent change in the position of the medium particles. Now, think about that sentence. A wave is a type of disturbance. It moves through a medium, taking energy along with it. Now, that energy can cause the particles in that medium to shift their positions. But when the wave crosses, they return to their previous position. So that tells you what a wave is and what it does. A disturbance that takes energy along with it as it moves through a medium. It can cause the medium particles to change their positions, but it can never be a permanent change. As the wave crosses, they return to their positions. Now, what is a pulse? A pulse is a small disturbance with small energy that dies off quickly. A pulse is a small disturbance that dies off quickly. What does that tell you? A disturbance with small energy that gets easily exhausted and stop moving, stop carrying energy along. So you can replace pulse with ripple, because ripple is actually a very small disturbance in a medium. Medium can be solid, it can be liquid, it can be gas, it can be space as well. Okay, now what is phase? Phase is a term that tells you the position of a particle from the source of the wave. A phase tells you the position of a particle from the source of the wave. Now, you remember the expression we wrote for the displacement of a particle in a medium as the wave passes. This y represents the displacement of a particle in a medium. A represents the amplitude. Of course, omega there, W is angular velocity. Of course, T is time. And phi is the phase difference. Now, the whole of this inside this bracket is the phase of this wave. If you're asked to calculate the phase of a wave given an equation, this is actually the expression you need to calculate the phase of a wave. Now, I want to use this diagram to show us a little more about phase. Now, imagine I use a rod and strike water surface here. Because my rod is a straight rod, it's going to generate plane straight waves traveling from left to right. As the waves are going, carrying energy, moving horizontally, you see that this point, this point, this point, this point, this point, they are at the same distance from this source of the wave. The distance from here to here is the same from here to here, the same from here to here, the same from here to here, of course, the same from here to here. You say that these points are in phase. They are at the same distance from the source of wave. They are at the same state of disturbance from the source of the wave. Now look at this point again. This one, this one, this one, this one. The distances from the different points to the source of the wave, the same. So they are at the same state of disturbance. They receive the same energy from the wave source per time. So you say those points are in phase. To calculate the phase of a wave, I will repeat it again. Go to the wave equation. This expression inside this bracket here is the phase of the wave. Now, what is phase difference? Phase difference, mathematically, if you want to calculate it, phase difference is given as this phi inside here only. This phi only is phase difference, and the expression is this. We explained this in the previous video we made on progressive wave equation. So it tells you the difference between the position of a particle at a point and the particle at the source of the wave. The difference between the position of a particle at a time and the position of the particle at the source of the wave. So it's called phase difference. You can as well calculate the phase difference between any other two particles within the medium as the wave travels. Now let's talk about wave number. Wave number is a very important concept. Wave number is the number of cycles per distance of a wave. Is the number of cycles per distance of a wave. The symbol for wave number is K. Is number of cycles over distance. Let me write this right. Cycles per distance. For one cycle, the angular distance is 360 degrees, which is written as 2 pi. Distance in one cycle is the same thing as the wavelength of the wave, given as lambda. So we can see that wave number, which is number of cycles, remember for one cycle now, which is the number 1, the angular distance is 2 pi over the wavelength. That will give you wave number. And you see 2 pi is just ordinary number, so it doesn't have a unit. You can just say 1. Unit of wavelength is meter. So the unit of wave number is per meter. Per meter is written this way. Per meter. That's the unit for wave number. Number of cycles per distance. Now, another important thing you need to know about the wave, as we've listed here, is wave front. Wave front is a plane that carries all points that are at the same distance from the source of the wave. A plane or a line carrying points that are at the same distance from the source of the wave. Again, wave front is a plane carrying points that are on the same state of disturbance from the wave. So for a plane wave, this line is a wave front, this other line is a wave front, because all the points on it have the same distance from the source of the wave. This line equally is another plane wave. Now you can see a wave spreading out from a point this way. If I draw a line here, these 4 points are at the same distance from the source of the wave, 0. So this line from here to here to here to here is called a wave front. Another distance here, look at these 4 points again. They have the same distance from the source of the wave. So these 4 points are in phase, the same distance from the source. A line joining points that have the same distance or the same state of disturbance from the source is a wave front. This is a wave front. This is another wave front. Of course, for a plane wave, this is a wave front. This is for a circular wave. Now, lastly, what is a wave propagation? Wave propagation is how a wave moves through a medium. Wave propagation is how a wave moves through a medium. Why? We have transverse waves, we have longitudinal waves. Their direction of movements are always different from the direction of vibration of the medium particles for transverse wave, while for longitudinal, the particles vibrate in the same direction as the wave. So how each wave moves through a particular medium is what we refer to as wave propagation. For electromagnetic waves, for instance, they don't need a material medium, they travel through space. So how the electrical and magnetic poles vibrate as waves move in space is also referred to as wave propagation for electromagnetic waves. So I hope these descriptions will help you in your journey studying waves. If you have any question, any observation, any comment, contribution, please feel free to comment, like, and share. And equally, you can send me DM on Dr. Ray's class. If you have any question on any topic on waves, please feel free to contact me. Or if you have any assignment you need help on, I'm always here to help you and listen to you. Thank you.